longest side. The timer starts now. Time's up. So I hope you enjoyed solving the problem, and afterwards I'm going to show you the proper solution and compare it with your answers. So let us go on with the solution of the problem. First is to illustrate like this. So this is the house of Lito, and he decided to take a run for about 800 meters, and he stopped here and took a rest, and after taking a short rest he continued running for about 1 kilometer, or that is 1000 meters. And our problem is asking the distance from the present location of Lito from their house as indicated by the broken line. So this broken line here indicates the distance of Lito and their house. And observing the diagram, it resembles, or it shows a right triangle. And a right triangle is a triangle with a right angle on it. And in this particular situation, we have a right triangle here. And the only theorem that can be used in solving such kind of triangle is the Pythagorean theorem. So you already discussed this theorem when you were in your lower grades. So this is just review for you. So the Pythagorean theorem is the square of the longest side is equal to the sum of the squares of the other two sides. Or in other words, c squared is equal to a squared plus b squared. So c is located here. As we have said a while ago, it is the longest side. And a is located here, which is the shortest side. And b is located here, which is the longer side. So to solve the problem using the Pythagorean theorem, we have c squared equals a squared plus b squared. You just simply substitute the values of a and b. So a is 800 meters and b is 1000 meters. So taking the squares of a and b, we have 800 squared, or that is 800 times 800, we have 640,000. Then meter square is square meters. And the other side, we have 1000 squared will give us 1 million, or that is 1000 times 1000. And we have meter will become meter squared. So taking on or continuing on the process, we have, since we have same units, which is the square meters, so we can add them up. So 640,000 plus 1 million will give us 1,640,000 square meters. So we are looking for c and not c squared. So we're going to eliminate square by extracting the square root of both sides. So we have the square root of c squared is equal to the square root of 1,640,000 meters squared. So simplifying the equation, we have c. So you now observe the square is now eliminated and became c. And extracting the square root of 1,640,000 will give us 1,282.62. And extracting the square root of meter square is meter. So we can now conclude that the distance of Lito from their house is 1,280.82 meters. We will take another example, and this time it is in a graphical form. So we have 3 points, which is point A, point B, and point C. They are plotted in a Cartesian plane. So we have here their coordinates. The coordinates of A is 2, 2. The coordinates of C is 8, 2. And the coordinates of B is 8, 9. The x-axis for the coordinates of, or the x-coordinate of point A is 2, and its y-coordinate is 2. The x-coordinate of point C is 8, and the y-coordinates of point C is 2. Same is true with point B. Its x-coordinate is x and its y-coordinate is 9. The problem is we're going to solve for segment BC as highlighted by the color blue, or the vertical part, vertical segment. And then we also ask to solve for the distance of point A and point C as highlighted by the color red. And we'll also solve for the segment AB, or the distance from point A to point B this side here. So to start with, we'll start with segment BC, and we will get the distance from BC by taking the absolute value of the difference of the y-axis of point B and point C. So we have y sub 2 minus y sub 1. You may be asking why we only take the y-axis of these 2 points. It's because this segment is a horizontal, it's a vertical segment. So we only need to take their y-axis. Substituting the given equation, for y sub 2 we have 9, and y sub 1 we have 2. Taking the difference of the 2, we have 7, and the absolute value for 7 is 7. So therefore, the distance of point B to point C is 7. Now there is another way, or the easiest way to find for the distance between these 2 points. We just simply count the number of units between them. So we have 1, 2, 3, 4, 5, 6, and 7. So that is 7 units. Therefore, there are 7 units between point B and point C, and that is their distance. Now let's take a look at the solution on how to find for distance AC, or segment AC. So since it is a horizontal segment, so we only need to take their x-axis. So we have to take the absolute value of the difference of the x-axis between those 2 points. So x sub 2 minus x sub 1. Substituting the given equation, we have x sub 2, which is 2, and we have x sub 1, which is 8. Subtracting the 2 numbers, we have negative 6. And taking the absolute value of negative 6 will give us 6, and therefore the distance, or the units, or the number of units between point A and point C are 6 units. Again, just like segment BC, we can just simply count the number of units between the 2 points to give us the distance. So from point A we have 1 unit, 2 units, 3, 4, 5, and 6 units. So if you have to find for the distances of the plotted points between 2 points in if they are, whether it be a vertical or a horizontal line, you just simply count their number of units between them. I hope that is clear to everybody. Now let us go in solving for segment AB. Now this is a bit longer than the other 2 sides because it is the longest side. So we need to apply the Pythagorean theorem. And the Pythagorean theorem is the square of segment AB plus the square of segment AC and the square of segment BC. Now I retained the color so that you can follow easily where those numbers are coming from. Now let's continue in substituting. So we all know that taking the segment AC, we only need to subtract the x-axis of these 2 points. X-axis, why? Because it is a vertical line. So we only need to take the x-axis of the 2 points. So x sub 1 minus x sub 2. Same is true with BC. It is a horizontal line, so we only need to take the difference of their y-axis. So substituting the given equation again, we have x sub 2 which is equal to 2 and x sub 1 which is equal to 8, y sub 2 which is equal to 9, and y sub 1 is equal to 2. Simplifying the equation, we have 2 minus 8 will give us negative 6, and 9 minus 2 will give us 7. Simplifying again the equation, the square of negative 6 or negative 6 times negative 6 will give us 36, and the square of 7 or 7 squared is 49. Combining the two numbers, we will get 85. 36 plus 49 is equal to 85. Now we are not done yet because we are looking for AB here. We are looking for AB and not AB squared. So the square should be eliminated, and as we applied in the previous example, we just need to extract the square root of both sides so that the square there will be eliminated. So the square root of AB squared is equal to the square root of 85. Simplifying the equation, we will have AB is equal to the square root of 85. Now, if you want to simplify this, be sure that the radicand is a perfect square. If not, then you can leave it that way, or you can give a decimal number to get the exact value of square root of 85, and the square root of 85 will give you 9.22. You may be asking which of the two values can be used as the distance. The answer is they can be used both. It depends on your preferences. If you want to use a radical number, it is okay, and if you want to use a decimal number, it is also okay. So if you understand a decimal number better than a radical number, then you may use decimal number. Anyway, they represent the same value. So that is how to solve for the distances of the points in a right triangle that is plotted in Cartesian plane. So I hope that is clear to everybody, and let us summarize our lesson, or let us summarize the steps or the formula by this figure. So we have a right triangle here. We're looking for point A and point B. So we have x sub 2 and y sub 2, x sub 1 and y sub 1. The formula for the distance formula is AB, or segment AB, or sometimes they denote this as D, small d, but most of the time they use AB. It's equal to the square root of the quantity x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So you may apply those formula if the given figure is a right triangle, or even if it's not a right triangle, if you find it, if you can have the coordinates of the 2 points, then you can use this distance formula.